All right, let's get you ready to absolutely ace your GCSE computer science exam. We're going to dive deep into one specific bit, section 2.4 of the OCR J277 spec, all about Boolean logic.
Okay, let's jump right in. If you've ever flipped through a past paper and seen all those weird symbols and tables and thought, what is going on? Well, you're in the right place. Stick with me and you'll know exactly how to handle them.
So what even is Boolean logic? Honestly, it's the secret language that all computers speak. It's a world where everything, and I mean everything, is either true or false. That's it. And for computers, we just use a 1 for true and a 0 for false. This super simple two-choice system is how literally every computer makes every single decision. And here's where it gets really cool. You take these dead simple true or false ideas, you start combining them in smart ways, and suddenly you can build these unbelievably complex systems. It's wild. Everything from your phone's calculator to the most insane video game graphics is just built on top of this one basic idea. So how do we actually do this combining? Well, it all boils down to 3 basic tools, or logic gates, that you absolutely have to know for your exam. Think of them as your Lego bricks. You've got and, or, and not. Let's look at each one. First up, we've got the AND gate. Now this one's the strict one. Think of it like this. To go on a school trip, you need a signed permission slip and you need to have paid the fee. If you're missing even one of those, you're not going, right? The AND gate is exactly the same. For the output to be true, or 1, every single input has to be 1. No exceptions. And here it is. This is the official symbol and the truth table straight out of your OCR spec. So you'll want to get this memorized. Look at that table. See how the output column is only 1 on that very last row? That's because it's the only time both input A and input B are 1. Next up is the OR gate. This one is way more laid back. Imagine you're at a coffee shop and they take cash or card. As long as you have one of them, you can get your coffee. The OR gate is just like that. The output is true as long as at least one of the inputs is true. And this shows you the difference perfectly. Again, this is the official stuff you need to know. Just look at the truth table. See how many more 1s you get in the output column compared to the AND gate? As long as there's a single 1 on the input side of a row, the output is a 1. And finally, the NOT gate. This one's the easiest of the bunch for sure. It only has one job. It takes a single input and just flips it. That's it. You give it a 1, it spits out a 0. You give it a 0, you get a 1. People often call it an inverter because, it inverts the signal. And as you can see from the official diagram, the truth table is about as simple as it gets. If A is 0, the output's 1. If A is 1, the output's 0. Done. Easy peasy. Okay, so we've met our 3 main gates, but how do we actually use this stuff to score points in an exam? Well, that's where truth tables come in. They are your secret weapon for showing how any logic circuit is going to behave. Seriously, don't let the fancy names scare you. A truth table is just a simple, organized chart. It's a way to make sure you've thought of every possible combination of 1s and 0s going in, so you can figure out what comes out the other end, step by step, without missing a thing. Right, now for the fun part. Let's put it all together. See, in your exam, you're almost never going to see just a lonely little AND gate. The real test is understanding how you can chain them together to do more powerful stuff. So, have a look at this. This is a classic exam-style problem. We've got 3 inputs, A, B, and C. You can see A and B go into an AND gate first. Then, whatever comes out of that gets mixed with C in an OR gate, and that gives us our final answer. So the big question is, how on earth do you solve it? Well, the trick is not to panic and try to do it all in your head. The key is to just trace the path of the 1s and 0s step by step, from left to right. Here's the game plan. First, you just focus on that first gate. Figure out the result of A and B. It's actually a good idea to add a new column to your truth table just for this middle step. Then you take that new result and you treat it as an input for the next gate. Finally, you solve that second gate. In this case, you take your middle result, or C, and boom, that's your final output. So, when it comes right down to it, what do the examiners actually want you to be able to do? Let's make this super clear. This is your personal revision checklist, taken right from the official specification. Okay, focus your energy on these 5 things. You have to know the truth tables and symbols for and, or, and not like the back of your hand. You've also got to be comfortable creating or fixing logic diagrams in truth tables. And most importantly, you need to be able to handle diagrams that have more than one gate. If you can nail these 5 skills, you are going to be in fantastic shape for the exam. So there you go. You've got the tools you need to tackle Boolean logic. And just to leave you with a final thought, think about whatever device you're watching this on right now. Inside its processor, there are literally billions of these tiny, simple and, or, and not gates all firing away. Kind of mind-blowing, isn't it?